So this is 9-4. Again, so we already did the 9-6 part of these notes. I'm going to do the rest of it. The 9-4 was what? 9-4 and 9-5 is what your quiz was on. So I said I was going to give it back to you last week, and then I totally forgot to give it back to you this last week. So I will be giving you that back today. That's 9-4 and 9-5, which is your parametric equations and your polar with the coordinates. So not the polar graphs, but the polar coordinates. So 9-4, we started, and this was where that T chart comes into play. So hopefully, and most of you did pretty well on this on the quiz. Like you had T is the first one. You'll have a T chart just like you had on your quiz. It will give you an equation. It will give you an X equals, and it will give you a Y equals, and then it will give you a parameter. So like if it said -2 less than or equal to theta, which is less than or equal to, not theta, sorry, T, which is less than or equal to 2, and then I would know that means I have to plug in -2, -1, 0, 1, and 2, and then you plug them into whatever equations are given to you. So I'll just make something up. Like let's say this is T plus 4, and let's say that this is T minus 6. So if I were to take and plug these points in, I would plug in -2 plus 4, which is -2. I would plug in -1 plus 4, which is 3. I would plug in -0 plus 4, which is 4. 1 plus 4, which is 5. 2 plus 4, which is 6. And then I repeat that process for the y. So if y is t minus 6, then I would get -2 minus 6, which is -8. -2 minus 1, -3. Actually, sorry, I wrote that wrong. For which one? Oh, yeah, this is positive. Thank you. -1 minus 6, which is -7. 0 minus 6, which is -6. 1 minus 6, which is -5. And 2 minus 6, which is -4. And then you put those two together to get the coordinates that you're going to plot on your axis. So 2, -8, 3, -7, 4, -6, 5, -5, and 6, -4. And then you're going to draw that on your coordinate plane. So I will also provide you with your coordinate grid. You just have to then plot those points. All right, so I would get 2, -8, 3, -7, 4, -6, 5, -5, 6, -4. This time it's a line. And then you want to connect them. Sometimes it's a parabola shape. Sometimes it's like a weird half a parabola shape. Whatever it is, you want to connect them. And then don't forget your arrows. So the arrows have to go from the smallest t pointing towards the largest t. So I want my arrows to be pointing towards that last point that I plotted, which is 6, -4. So order is important when you're figuring that part out. I would say most people got that question right on the quiz. If they didn't, it was something silly. Like it wasn't like you completely didn't know what you were doing. There was some silly stuff, but and not very many forgot the arrows. But that is a common mistake. So just make sure that you don't forget your arrows. Okay, for the second part was eliminating the parameter, right? So this means get rid of t, because t is the parameter. So if I have two equations like x equals 3t plus 7 and y equals, I'm going to make it easy just so that we can go through the process, t minus 6, but this could be anything. This could be square roots, this could be squareds, all that stuff. Then the goal is to solve one of these equations for t. Obviously, make it easy on yourself. Pick something that's easy to do. So probably the second one. I'm going to solve for t by doing t equals y plus 6. And then take that equation and plug it into the other equation in place of the t. So x equals 3 times y plus 6 plus 7, 3y plus 18 plus 7, or 3y plus 25. Yep. Sure. You can either make it x equals or y equals because it's going to depend on the type of equation you get, which one it makes the most sense. So if I had this, obviously I could leave it like that, or because it's a line, you would actually probably, I mean, you're not graphing it, but if you were to graph this, you would get it into y equals mx plus b format. But for now, because you're not graphing it, you could do y equals or x equals. God bless you.
It doesn't, so the test doesn't.
Correct, because you're not graphing this. Then the third thing from 9.4 was the reverse, finding the parametric equations if you're given one parametric and one rectangular. So you might be given like a y equals t minus 6, where one of them has a t in it, and then the other one would not, like 2y, maybe minus 1, something like this. So the goal is obviously look for the one that has the t in it, which in this case is the y. The lines are going to be there for, I think there's two lines. One is an x equals and one's a y equals. You want to write out the ones that have t's. So this is t minus 6. If it wasn't solved for y, I would isolate the y, but it's already solved for y. So then I take and plug into the other equation in place of the y. And I get x equals 2 times t minus 6 minus 1 to t minus 12 minus 1 to t minus 13. And then there's the other one. So you need two equations at the end, one x equals and one y equals, and they both have to have a t. Yeah. Questions on 9.4. So same three topics that have been covered before, okay? Same three topics that were covered on your quiz. Okay, then came 9.5. So 9.5 was just your polar coordinate points. So the first part was graphing and finding additional points. So remember, if you had, like, let's say I have 2 and pi over 3. I'm going to go to where this would be pi. I'm going to go to pi over 3, which is this one. And I go to the second ring and I plot a point. This would be 2 pi over 3. If it's a negative angle, so 2 negative pi over 3, let's say, there's two ways to find the negative angle. One is go clockwise instead of counterclockwise like we normally do. The other is find it where it's positive, which would be here. Fold your axis on the x-axis, and this would be your negative pi over 3. And then again, go to the 2, plot your point. And then you could also get a negative r. So let's say it's negative r and pi over 6. I would find pi over 6, which is here, but instead of going towards pi over 6 like we would normally do if it's a positive r, we go away from pi over 6, and that's where it's negative. So you just got to make sure you know how to plot any kinds of points, any combinations there. Yep.
Are you going to get the unit circle like on the quiz?
So the plan was actually to let you fill it out tomorrow in class, like so you don't eat up that time, but I'm not here, so I may just give you a unit circle. Yeah, depends on my mood later today when I make those copies. Yeah. No, negative 5 pi over 3. These are not the same coordinates. These are different coordinates. Yeah, these are different.
I thought you were asking us to find.
No, I just said make sure you can plot all different kinds of coordinates. Then comes find additional points. So if it's find an additional points, you can either use your graph, right? Or you can take, if it's r theta, you leave r as r, take theta, add and subtract 2 pi. I made that point up. I said plot these points. These are not the same points. 3 completely different examples. They're not related. And then r theta, the other option is change the sign on r. So if it started positive, I would change it to negative. If it started negative, I would change it to positive. And then take theta, you're going to add and subtract odd multiples of pi, which could be pi or it could be 3 pi, depending on how big or small your initial point is. The goal here is going to be to get it between negative 2 pi and 2 pi. Like that is going to be in the instructions. Not including 2 pi. So this won't be there. So you won't give 2 pi or negative 2 pi as an answer. It would not include them. Questions on plotting or finding additional? Okay, then came the conversion from polar to rectangular and rectangular to polar. So if you start rectangular, actually let's start polar. I think we did it in that order. If we start polar and we go to rectangular, which means I'm starting r theta and I'm going to xy. Then the ones without a calculator, well, either ones you could do, r cosine theta for the x and r sine theta for the y. If you don't have your calculator, those will be unit circle-based thetas. So they will be ones that you could find on your unit circle or coterminal to that. If they are not, that's when you use your calculator, which we'll talk about in, like once I get through the two conversions. So if I just wanted to convert, let's say I pick the last one we did. Say I wanted to convert -2 pi over 6 to rectangular. I would do -2 cosine pi over 6, -2 sine pi over 6. At pi over 6, the coordinate point is √3 over 2 and 1/2. The cosine there is √3 over 2. The sine is 1/2. So I'd end up with -√3, -1. And if you compare that with where you graphed that point, we graphed this point. It's here. It's in my third quadrant, as would -x and -y. So -√3 and -1 would also be in the third quadrant. So they should end up in the same quadrant. So we also went back the other way, rectangular polar, which means you're going to get an xy, and your goal is an r theta. So we find r by doing the square root of x squared plus y squared. And then we do tan of theta equals y over x. And the goal there is to solve for theta. So you're going to get a value that would be a tangent on your unit circle. I will tell you that if I give you a unit circle, I'm not going to add the tangents on, so you need to know those, right? So your over 3 is √3. Your over 4 is 1. Your over 6 is √3 over 3 for tan, okay? 0 is 0, and pi over 2, or over 2 is undefined. So if I got something that said like tangent of theta is undefined, then I would know I would pick either the top or the bottom. Remember, there's always going to be two answers for these. And you pick theta based on the quadrant from the original point. So if my original point has like a -x and a +y, I would know I'm picking quadrant 2. Whatever the tangent is in quadrant 2. If I've got a -x and a -y, now I know to pick the angle that's in the third quadrant. Yeah, like if you went from 3√3. Here, actually, let's just do this one. No, it's fine. 3√3 and then -3. So my r is square root 3√3 squared plus -3 squared. So this becomes 9 times 3. That's 27 plus 9, square root 36, which is 6. And then tan theta would be -3 over 3√3. The 3's cancel. I get -1 over √3, and that gets rationalized to -√3 over 3, because you'd have to multiply both the top and the bottom. So then I'd find, first of all, without even knowing your unit circle, you should know that √3 over 3 is an over 6. And then because it's negative, I know, and it's negative, it means it's in the second quadrant or the fourth quadrant, because that's where tangent's negative. But based on my original point, being a positive x and a negative y, I would know I'm in the fourth quadrant. And that over 6 is 11 pi over 6. So that's how I know to pick that for theta. So then r theta would be 6, 11 pi over 6. That actually have the calculator part, you will actually start with those. So the calculator questions are going to be conversions from polar to rectangular or rectangular to polar. And they will not be unit circle based. So that's the difference. Like that's how you would know, one, it's going to say calculator portion. But two, you wouldn't be able to do them any other way because they are not unit circle based. So let's say it's polar to rectangular. It might say something like 5 and then 3 pi over 7. And I want to get that into rectangular format. Two ways to do it. One can be done with any scientific calculator. And that is to do it 5 cosine 3 pi over 7. And then 5 sine 3 pi over 7. Making sure your calculator is in radians. So if I don't have the shortcut key or you don't know how to use it, you can just use that. Just use the formula that we've been doing. All right, so if I'm doing that, I literally just make sure I'm in radians, and then I do 5 cosine 3, I hit the pi button, divided by 7, and that's the x coordinate, 1.1, I think it says around to the nearest hundredth, so 1.11. And then 5 sine 3 pi divided by 7. And I get 4.87. It should make sense that they're both positive, like 3 pi over 7 would be in my first quadrant and 5 is positive, so it should make sense that they're both positive because it would overlap. That's one way to do it. The other way is using the shortcut keys on, like if you have the TI-84, it has shortcut keys. And for that, you need to be in radians and you need to be in polar. So your mode... No, this is the only 2 questions you're using it for. It goes to radians, not to polar, but to radians. So then I'm going to second quit this menu. The shortcut keys are underneath your angle menu, which is above your apps. So if I do second apps, this is going polar to rectangular. So I'm going to do polar to rectangular x. And I do 5, 3 pi divided by 7. And there's the x coordinate. The comma is above the 7. I'm doing the x. So polar to rectangular and type in your initial question. 5, 3 pi over 7. Then I'm going to do polar to rectangular y. Same thing, 5, 3 pi divided by 7. And that's the y. So you're going to have to do it twice. Once for the x and once for the y. Second, apps, the angle menu that has that DMS. But you're going to do, this is polar to rectangular. So we're doing polar to rectangular x and then polar to rectangular y. Honestly, I don't think that's that big of a difference as far as a shortcut goes for polar to rectangular. For rectangular to polar, I think it's a little bit easier. But for that one, I don't think it's that hard to do 5 cosine 3 pi over 7 and then 5 sine 3 pi over 7. So to be honest, I don't know if you need it for that one, okay? For the second one, where you've got like rectangular to polar, let me pause this, move you out of the way. So this would be like, let's say it said my rectangular coordinate point is, I don't know, 1.25 and negative 3.2. Actually, I think they kept them both positive so that we don't mess with anything that's...
This stays in polar.
It would stay in polar and it would stay, yeah, polar and radians. So this time I'm going to, the long way around, r would equal the square root of 1.5 squared plus 0.65 squared. And you let your calculator do that work. So second square root 1.25 squared plus 0.65 squared. And I get a radius of 1.41. And then I would have to do tan theta is 0.65 over 1.25, and I'd inverse tangent that. So second tan 0.65 divided by 1.25. And I get theta is 0.48. So my R theta is 1.41 and 0.48. If I do it the longer way.
Does exactly mean exact answer?
What do you mean?
Can they range?
No, it's going to be exact. Yeah.
Don't tell us what you want.
It's not exact because it's rounded, but it should, your rounded should exactly match my rounded. Yes, it says what to round to. I think it's 100th, but it says what to round to. So then the shortcut key is second apps. This time I'm rectangular to polar R, so R to PR. And I type that point in 1.25, comma, 0.65. And there's my R. Are you doing the shortcut key?
Yeah.
You did R to PR. And then R to P theta. Same point in 1.25. Oops. 1.25, comma, 0.65. Or 0.65, that doesn't matter. And there's my theta, same as before, 0.48. So if you're comfortable and you're quick, do both. Check them, okay? But this is the first two questions that you're gonna get. You're gonna start with those and then you're gonna put your calculator away and then you're moving to the rest of them. So you cannot, I repeat, cannot spend more than 5 minutes on that question, on those questions together. I would say if you could do it in 2, even better, because you can go back to it, okay? But the rest of the stuff, all that graphing and all those other questions obviously take a little bit longer. All right, questions on 9.495. So again, that's what was on your quiz minus the calculator portion. That was not on your quiz. All right, 9.6 is what we talked about on Friday. So we did the limicons, the rows, the limescates. I told you were going to get 2 graphs. So if you were a senior and you didn't watch the video, I did tell them they're going to get 2 graphs. One for sure, limicon. And if it's a limicon, you're going to then classify it as either the inner loop, the cardioid, the dimpled, or the convex. And then you're going to give me the symmetry. And then you're going to plug in 5 points for a for a limicon. And then use the reflection to get the other side. At minimum 5 points. If you don't know how to reflect, then you have to plug in more. Then rows, okay, you can maybe get lucky with 1 or 2 points if you're working backwards. So if I solve for R and I find where a petal is, if it's got 3 petals, that might be all you need between that and the symmetry. If it's got more, and I didn't really go heavy on how many because it's going to take you longer, but let's say it's 4 and you find 1 and you know how to reflect it, maybe you only have to find 1 more to then reflect that, and then you would know where they are.
Which ones can you work backwards for?
The rows, that one, because you plug in for R.
And the circle?
And then you can work backwards on the circle, but I said the rows and the lemniscate is the ones I would work backwards on. Technically, you can work backwards on any of them, but those are the 2 you want to. Yeah. Like plug in for R to find the petal. Yeah. Same, so lemniscate, I would do the same thing. I would identify it's a lemniscate. I would figure out, obviously that means it has pole axis symmetry. Find the loop length and plug that in to find where that loop is. And then honestly, with a lemniscate, 1 point should do it, because then you should be able to know what your graph looks like. A circle, also 1 point should do it. A circle with cosine is either to the right or the left. A circle with sine is either above or below. If you knew that, if you knew it was cosine, you can either plug in 0 or pi and find your edge. And if you knew it was sine, so it's above or below, then you can plug in pi over 2 or 3 pi over 2, and you can find the point, and then you'd be done. So you will get one of those 3, either rows, lemniscate, or circle. The R equals a number is a special kind of circle. That's just a 0, 0 with a radius of 2, and that will not be on your test. It may come back midterm, on final, but it will not be on this test.
Isn't the R just how far we go out?
Yep.
So we don't have to plug one if we know what R is?
You just have to know which direction it goes.
Yeah.
Yeah. Vicky.
For the circle, can you not plot any if you know that A is?
Yeah. If you know what you're doing, it's easy. Yeah. Okay, and then 10-1. So this was all your 3-dimensional stuff. So when you're graphing a point, and you're going to see this kind of in 2 ways. One, it's going to actually give you a coordinate point. So let's say it's like, 3, -5, 2. Pay attention to where your, so this is hard to see, but this would be x, this is an x, this is a y, and this is a z. I gave you the exact same graph on your test. So this would mean I move forward 1, 2, 3. I would put, that would be an x of 3. -5 means I move to the left 5. So you can either go to -5 here and come parallel to your x-axis, or you can go 1, 2, 3, 4, 5, scoop your way to the left, okay? Because you're going from that x, negative. Then the +2, and this is the one where you're going to probably be the least accurate, but you're literally going to either give me dots or give me those little scoops to show that you moved up 2 places, and then that would be your coordinate point. You don't go up to 2 and plot that point because this is dipped forward, so it is not at exactly 2 vertically. So you're just going to be careful. And again, if you can either give me dots to show that or scoop, I don't care how you show it, but you're going to show it to me that way.
So if you see like if the graph is weird, you see that we went the right spaces.
As long as it's reasonably spaced. Yeah. The other way you're going to see this, and I think it's a question, Maria, you have it open, right?
Yeah.
There's something can you go to 10-1? Number 3 on the PDF review, like on the one from the book, says something like in front. So it's like 4 in front, maybe 3 to the left, and 5 up, or 5 above is the wording. Obviously, there's a question on the review like that. Yeah. Why did I put it there? I don't want it there. That's not distance. I want it up here. Sorry. It's still coordinate point. So 4 in front. And now I don't remember what I just said. 5 left. 3 to the left. Thank you. And 5 above. So front or back is your x if you think about it, right? If it's front, that means it's a positive x. If it's back behind it, then it would be a negative x, right? So that's 4. The left and right is your y. So if it was right, it'd be a positive y. If it's left, it's a negative. And then above and below is your z. So if it's above, it's positive, and it's below, it's negative. That's it. That should be super easy. Don't let the words throw you off. Forward and back is your x. Right and left is your y. Up and down is your z. Again, this is like number 3 from the review.
The graph is the same on the test.
That graph is the exact same graph on the test. Yep. Then came the distance. So if you're looking for the distance between 2 3-dimensional points, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2, sorry, minus z2, holy moly, z1 minus, squared. So z2 minus z1 squared. And then if it's a square root, obviously it can be simplified. It needs to be. If it is already simplified, you're done.
Which question is worth the most points?
The graphing. Yeah. There's some that are 10. There's some that are 12. They have multiple parts difference. 2. Yeah. All right. Then the midpoint you add. So you add the 2 x's. You divide by 2. You add the 2 y's. Divide by 2, add the 2 z's, divide by 2. And you keep that in coordinate point form.
Which one's the one? Oh, we're not about to find the standard form.
Yep. That's the sphere. So the sphere is x minus h squared plus y minus k squared plus z minus j squared equals r squared. So you'll see 2 things with this, like you'll get information about there's 2 different kinds of questions with the spheres. You're going to get information about the sphere and you're going to have to find the equation. So let's say you're given, I think let me see your review again. Sorry, go to 10. This is the one that says endpoints. So it kind of puts, I would say it puts 5 and 9 together, where if you're given the endpoints of the diameter. So if it's 1, 2, 3, I'm making up numbers, but 4, 5, 6. Let's say I gave you those were the endpoints of your diameter, and you have to find the equation.
How would you know which ones?
And hang on a second, center and radius. How did you know what? Which one's the 1 and 2?
Which one's the X, Y, and Z? Which one's the...
So they're both X, Y, and Z. You don't have the center yet. So center is your H, K, J. So that's the first thing you're going to have to find. You're going to find the center by doing the midpoint formula. I should have picked even numbers to make my life easier, but here, change this. The midpoint with those. So if those are the endpoints of your diameter, right? The center of it. Right, like if you could picture 1, 2, 3, that's 1 point. 5, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. God bless you. Those are the endpoints of the diameter of the sphere. So the center is going to be the midpoint between them. So you're going to use the midpoint formula. It would be 1 plus 5 over 2, 2 plus 6 over 2, 3 plus 7 over 2. I'd get 6 over 2, which is 3, 8 over 2, which is 4, 10 over 2, which is 5. That's the center. So that's the H, K, J. That would answer one question because this is multiple part. That tells you part of your equation. It would be x minus 3 squared plus y minus 4 squared plus z minus 5 squared, but you still need the radius. So you have two choices. One is, if I know the center and I know the endpoints of the diameter, I could actually just use the distance formula from my center to either endpoint. So I can grab this and I can grab one of these and use the distance formula, and that will tell me my radius. Right? Like the distance from the center to the endpoint of the radius of the endpoint of the diameter would be the radius length. That would be r. Or I can use this as the what I have here, the h, the k, the j, and then I can pick either other point to plug in as the x, y, z. So if I did that, I'd get 1 minus 3 squared plus 2 minus 4 squared plus 3 minus 5 squared equals r squared. So 4 plus 4 plus 4. R squared is 12, which is the part of the answer I was missing from here. That would be the equation. And then the radius would be the square root of 12, which would be 2 root 3. Then the last thing as far as the spheres goes is the complete the square. So you're going to have to complete the square. To put the sphere into standard form. So that's on the review too, but it would be like an x squared plus 2x plus y squared plus, I don't know, 8y plus z squared minus 16z minus 10 equals 0. And your goal is to group them all together. Again, I went easy as far as whole numbers go. Like you shouldn't have to be taking anything out of the off of the variable that's squared, okay? And then you just want to complete the square. So you have to do it for the x, for the y, and for the z. Do you want me to walk through that process, or are you okay from there? Okay.